So the best way to learn about how to write or name hydrocarbons, and again, hydrocarbons are the organic molecules in chemistry, is to probably show you how to do that. So you're going to need a couple tables here. Okay, so just lay a DS here and then move on to our skill set. So looking at skill number 2, tables P and Q are going to be ideal. So if you don't have them in front of you, pause the video and go get them. So we look at these hydrocarbons because they're exclusive to organic chemistry. And we are classifying these 3 homologous series from table Q. Okay, so we have alkanes, alkenes, and alkynes. So we're going to use table P and Q to answer some of the following questions. So in terms of bond type, how are alkanes, alkenes, and alkynes different from one another? We can see that the carbon bonds, okay, if it's a single, it's an alkane. If it's a double bond, it's an alkene. And if it's a triple bond, that's going to be an alkyne. Now that's just the way they look about for bond type, but there is a critical reason why there's going to be a double bond. And the reason that is because if you take away the hydrogens that are in the hydrocarbons, you are now creating a space so that the electrons of the carbon are going to now share and create these double bonds. So the word saturated basically means totally and completely saturated with hydrogen. So an example would be such as this. So this is what we call a saturated hydrocarbon. All of the bonds between the carbons are single, so this would be considered an alkane. Okay, so I'll just put this down here just to practice for you. Okay. And again, taking what else we know, okay, the only one that is saturated is an alkane. And the 2 that are going to be unsaturated are your alkene and your alkynes. And again, going along with the terminology, just so that we can practice what we know, this would be an alkene, and this would be an alkyne, all based on the fact that we have double and triple bonds here. So, unsaturated would be an alkyne, and an alkene would also be unsaturated. So let's take a look at, and again, we're focusing now on specifically table Q. So this is something that you need to have right alongside with you. Taking a look at this, we need to be able to write its molecular formula. So, going to count the number of carbons. So I have 4 carbons, and 1, 2, 3, 4, 5, 6 hydrogens. Now I can name this. I can name this because I can now use my table O. 1, 2, 3, 4. My prefix is going to be but. And my last name are going to be the last names of my homologous series. So this is going to be called butyne. And like we know about alkanes being saturated, alkynes are going to be unsaturated. So I'm just going to put a U there. Let's practice the next one together. This one, 1, 2, 3, 4 carbons. So also that prefix will be but. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Last name, ane. And the only one that is saturated. And last but not least, we're looking at a double bond. So I know its last name is going to be ene. 1, 2, 3 carbons. And 1, 2, 3, 4, 5, 6 hydrogens. My 3 carbon prop and that's going to be unsaturated. So another thing here that's kind of important, especially when it comes to table Q, is you can solve for this. This is something that we went over in class. This is the kind of the algebra piece to it. N is going to stand for the number. So if I have 3 carbons, that would be C3. And again, I'm going to use that same number, which is 3, and put it in this formula. So 2 times 3 plus 2 makes for 8 hydrogen. Hope this makes sense.